So our next topic is Chapter 6 or Module 6, EtherChannel. So there are scenarios in which more bandwidth or redundancy between devices is needed than what can be provided by a single link. So multiple links could be connected between devices to increase that bandwidth. However, spanning tree being what spanning tree is, and as we know, it is an enabled layer 2 protocol enabled by default on our Cisco switches. It will do what it normally does, and it will block redundant links to prevent switching loops. So a link aggregation technology is needed that will allow those redundant links between devices that will not be blocked by STP. That technology is now known as EtherChannel. So EtherChannel, again, is a link aggregation technology. It groups multiple physical Ethernet links together into one single logical link. It is used to provide fault tolerance, load sharing, increased bandwidth, and redundancy between your switches, routers, and servers. So it makes it possible to combine the number of physical links between the switches to increase the overall speed of switch-to-switch communication. In traditional EtherChannel, ports have to be contiguous, like 1, 2, 3, 4. You could not have combined varied ports like 5, 1, 5, 7, etc. However, in today's technology, the iOS now will allow for the inclusion of non-contiguous ports. But if you're utilizing an older version of EtherChannel, the ports have to be contiguous. Now, EtherChannel technology was originally developed by Cisco as a LAN switch-to-switch technology of grouping several fast Ethernet or gigabit Ethernet ports into one logical channel. When an EtherChannel is configured, the resulting virtual interface is referred to as a port channel. The physical interfaces are bundled together into a port channel interface as shown here. So it has many advantages, including the following. Most configuration tasks can be done on the EtherChannel interface instead of on each individual port, ensuring configuration consistency throughout those links. EtherChannel relies on existing switch ports, so there is no need to upgrade the link to a faster and more expensive connection to have more bandwidth. It includes load balancing, which takes place between links that are part of the same EtherChannel. It creates an aggregation that is seen as one logical link. When several EtherChannel bundles exist between two switches, STP, being what it is, may block one of the bundles to again prevent switching loops. When STP blocks one of the redundant links, it blocks the entire logical channel. So this blocks all the ports belonging to that EtherChannel. Where there is only one EtherChannel link, all physical links in the EtherChannel are active because STP will only ever see it as one logical link. EtherChannel provides redundancy because the overall link is seen as one logical connection, and the loss of one physical link within that channel does not create a change in the topology. The entire channel itself would have to go down to incur that change. It has certain implementation restrictions, however. Your interface types cannot be mixed. So for example, fast Ethernet and gigabit Ethernet cannot be mixed with a single EtherChannel. Currently, each EtherChannel can consist of up to 8 compatibly configured Ethernet ports. EtherChannel provides full duplex bandwidth, so that's up to 800 megabytes. Fast EtherChannel, or 8 gigabits, gigabit channels between one switch and another switch or host. Your Catalyst 2960 Layer 2 switch currently supports up to 6. The individual EtherChannel group member port configuration must be consistent on both of your devices. If the physical ports on one side are configured as trunks, the physical ports on the other must also be configured as trunks within the same native VLAN. All ports in the EtherChannel link must be configured as Layer 2 ports. Each EtherChannel has a logical port channel interface. So a configuration applied to the port channel interface will affect all the physical interfaces that are assigned to that interface. And that is precisely how we want you to proceed. Once you create that port channel, do that as your very first step. Bundle together the interfaces that you want to bundle together. And then don't go into them individually again. Always go into the port channel and configure it with speed, duplex, any parameters you want, trunk port, whatever you want to give it. Give it to the port channel and it will disseminate down to all of the interfaces included in that channel. EtherChannels can be formed through negotiation using one of two different protocols. Port Aggregation Protocol, or PAGP, which is Cisco proprietary, or Link Aggregation Control Protocol, LACP. These protocols allow ports with similar characteristics to form that channel through dynamic negotiation with adjoining switches. It is also possible to configure a static or unconditional EtherChannel without the use of PAGP or LACP. So PAGP is a Cisco proprietary protocol again. It aids in the automatic creation of that EtherChannel link. So when an EtherChannel link is configured using PAGP, PAGP packets are sent between EtherChannel capable ports to negotiate forming that channel. When PAGP identifies matched Ethernet links, it will group the links together into an Ethernet channel. The EtherChannel is then added into the spanning tree as a single port. When enabled, PAGP also manages that EtherChannel. So packets are sent every 30 seconds. PAGP will also check for configuration consistency issues and manage link additions and failures between your two switches. It ensures that when an EtherChannel is created, all ports have the same type of configuration. In EtherChannel, it is mandatory that all your ports have the same speed, the same duplex, and the same VLAN information. Any port modification after the creation of the channel also changes all other channel ports. PAGP helps create the EtherChannel link by detecting the configuration of each side and ensuring that links are compatible so that the EtherChannel link can be enabled when needed. It has modes that you need to be familiar with. In the on mode, this is going to force the interface to channel without PAGP. Interfaces configured in the on mode do not exchange those PAGP packets. PAGP desirable. This mode places an interface into an active negotiating state in which the interface initiates negotiations with other interfaces by sending those PAGP packets. PAGP Auto. This mode is going to place an interface in a passive negotiating state in which the interface will respond to PAGP packets that it receives, but it will not negotiate a PAGP negotiation. The modes must be compatible on each side. If one side is configured to be in auto mode, it is placed in a passive state, meaning it's waiting for the other side to initiate the EtherChannel negotiation. If the other side is also set to auto, the negotiation will never start because that side is waiting for the other side to stop the negotiation. Therefore, your EtherChannel will not form. If all modes are disabled by using the no command, or if no mode is configured, then it would stand to reason that EtherChannel itself is also disabled. The on mode manually places the interface in an EtherChannel without any negotiation. It works only if the other side is set to on. If the other side is set to negotiate, no EtherChannel will form because the side that is set to on does not do the negotiation. No negotiate between the two switches means, again, there is no checking to make sure that all the links in the channel are terminating on the other side, or that there is PAG-P compatibility on that other switch. So this table is going to show you the various combination of PAG-P on switch 1 and switch 2 and the resulting channel establishment. So if both sides are on, an establishment will be met. If one is on and the other one is desirable or auto, there is no channel establishment. If both sides are desirable, then there will be an establishment. If one side is desirable and the other side is auto, there will be an establishment. If the first side is auto and the second side desirable, there will also be an EtherChannel establishment. If they're both set to auto, neither will be creating a channel. So, on and desirable or auto is a no. Auto and auto is a no. Any other combination will result in a channel establishment. Now, within LACP, it is part of an IEEE specification 802.3 AD. It also allows several physical ports to be bundled to form a single logical channel. It allows a switch to negotiate an automatic bundle by sending LACP packets to other switches. It performs a similar function to PAG-P with Cisco EtherChannel, but because LACP is an IEEE standard, it can be used to facilitate EtherChannels in a multi-vendor environment. On Cisco devices themselves, either protocol would be supported. LACP provides the same negotiation benefits as PAG-P. It helps to create the Ether link by detecting the configuration of each side and making sure that they are compatible so that the EtherChannel link can be enabled. The modes are a little different for LACP. In the on mode, it forces the interface to channel without LACP. Interfaces configured in the on mode do not exchange LACP packets. In the LACP active mode, it places a port in an active negotiating state. In this state, the port initiates negotiations with other ports by sending LACP packets. LACP passive. This mode places a port in a passive negotiating state. In this state, the port responds to the packets that it receives, but again, it does not initiate LACP packet negotiation. So the table for LACP is as such, pretty similar to PAG-P. If both are in the on mode, then a channel is established. If one is on and the other is active or passive, there is no channel. If they're both active, there is a channel. If one is active and the other passive, there is a channel. If one is passive and the other active, there is a channel. If they are both passive, there is no channel. Now, guidelines and restrictions. EtherChannel support. All Ethernet interfaces, again, must support EtherChannel with no requirement that interfaces be physically contiguous. Speed and duplex. Configure all interfaces in a channel to operate at the same speed in the same duplex mode. VLANs must match. All interfaces in the channel bundle must be assigned to the same VLAN or be configured as a trunk. Range of VLANs. An EtherChannel supports the same allowed range of VLANs on all the interfaces in a trunking Ethernet channel. If the allowed range of VLANs is not the same, the interfaces do not form a channel, even when they are set to auto or desirable. So some things you have to be very careful about and check while you're trying to create these ether channels. In this figure, it shows a configuration that would allow an ether channel to form between S1 and S2. If these settings must be changed, you want to configure them in the port channel interface itself. Again, always create the port channel first. Make all your changes in the port channel. Do not make changes in individual interfaces that you have put into a port channel. Okay? So, create the channel first. Make all changes to the channel. Do not make changes to individual channels, individual interfaces. I'm writing and talking at the same time. It's not working well. Do not make changes to individual ports that are put in the channel. So any configuration that is applied to your port channel also affects those individual interfaces. Configurations that are applied to the individual interfaces, however, do not affect the port channel. So if I continue to make configuration changes to an interface that is part of an ether channel, it's going to cause problems with compatibility issues. Everything in the channel or all the interfaces in that channel must have the same compatibility. The port channel can be configured in access mode, trunk mode, which is most common, or in a routed port mode. So in this example between switch 1 and switch 2, you see that both switches have the same port configurations, and therefore an ether channel can be formed. Configuration is not really that intense, but do it in a step-by-step fashion. So, step 1, specify your interfaces that will compose the ether channel group using the interface range command. The range keyword allows you to select several interfaces and configure them together as one. Step 2, create the port channel interface with the channel group identifier mode. Make sure the mode is active in interface range configuration mode. The identifier specifies a channel group number. The mode active keyword identifies this as an LACP ether channel configuration. So here's where you need to know the difference between the modes of PAGP and the modes of LACP. Step 3, to change layer 2 settings on the port channel interface, enter the port channel itself using the interface port channel command followed by the interface identifier. So in this example, S1 is configured with an LACP ether channel. The port channel is then configured as a trunk interface with the allowed VLANs specified. As always, when you configure devices in your network, you must verify your configurations. If there are problems, you will also need to be able to troubleshoot and fix those problems. So there are a number of commands to verify an ether channel configuration. Show interfaces port channel command is going to display the general status of your port channel. This will also specify if the channel is layer 2 or layer 3. Show ether channel summary is going to display one line of information per port channel. The show EtherChannel port channel command is going to display information about a specific port channel interface. The show interfaces EtherChannel can provide information about the role of a physical member interface of that EtherChannel. All interfaces within that channel must have the same configuration of speed, duplex, native, and allowed trunks, and access VLAN on access ports, ensuring that these configurations will significantly reduce network problems related to your channel. Common issues. Assigned ports in the EtherChannel are not part of the same VLAN or not configured as trunks. Ports with different native VLANs cannot form an EtherChannel. Trunking was configured on some of the ports that make up the channel, but not all of them. It is not recommended that you configure trunking mode on individual ports that make up your channel. Always configure all your commands on the port channel once it is created. When configuring a trunk on your EtherChannel, verify the trunk mode on the EtherChannel itself. If the allowed range of VLANs is not the same, the ports do not form an EtherChannel, even when PAG-P is set to auto or desirable. The dynamic negotiation options for PAG-P and LACP are not compatibly configured on both ends of the EtherChannel. You cannot combine commands from the two different protocols. You must use one or the other. So in this figure, FA01 and 02 on switches 1 and 2 are connected with an EtherChannel. However, the EtherChannel is not operational. So when you do show EtherChannel summary and you use the rubric that is shown here, you see down below, when you look at the status of your EtherChannel, here, on port 1, port channel 1, it is down and is on a layer 2 switch. And it does say that it includes ports 1 and port 2, but they are also down. So this is not a functioning EtherChannel. View port channel configuration. So in this port channel configuration, you want to compare. So, show run, use your pipe symbol, begin interface port channel. So I can see interface port channel 1 on switch 1 is allowing VLANs 1, 2, and 20, and it is in switch mode trunk. When I look at my two individual interfaces as well, I see that they also have the same allowed VLANs 1, 2, and 20, and they are also in trunk. And I see that the group 1 mode is on. When I look at switch 2, I see they are both, it is also configured as a port channel 1. They are allowing 1, 2, and 20. Switch port mode is trunking. However, on the individual channels, it is allowing VLAN 1, 2, and 20. Group 1 mode is desirable, however. We cannot mix these two to form a channel. So I cannot have on one end of the connection and desirable on the other. So you have to go in there and correct your misconfiguration. To correct the issue, the PAG-P mode on EtherChannel is changed to desirable. EtherChannel and STP must interoperate. So for this reason, the order in which your EtherChannel related commands are entered is important, which is why you see interface port channel 1 removed and then re-added with the channel group command as opposed to directly changed. If one tries to change the configuration directly, STP errors will cause the associated ports to go into blocking or error disable. So remove the channel completely on switch 1 and then recreate it with the correct with the correct parameters of desirable. Don't just go in there and change it to desirable. If you give STP, there's just that little instance to block a port and put it in error disable, it will. So now when we verify, we can certainly see that our status down here has changed to SN up, or SNU. Okay, I am still identified as port channel 1. It is in use, and it is a layer 2 switch. I look into both of my ports. I am in tag P mode now. Before I didn't have a designated mode because they could not form a channel. And my FA1 and FA2 are both bundled in a port channel. This is what you want to see when you do your EtherChannel configurations. This right here is 100% functional. So again, EtherChannel, pretty simple to configure going forward. However, you need to pay attention to the steps that you configure it, follow suit, the modes, create your channel first, put your interfaces in the channel, and then going further after that, going forward after that, always do your changes to the port channel, not to individual interfaces.